All right, we are back. This is Math 200. We're looking at Chapter 6. We're in the packet, and this is the second part of 6.2. So we're on page 6 of the note packet, and we've got a problem that is tough because they've got this 21 in front of the x squared. So we did some unfoil factoring at the beginning, and that's when it's 1x squared, when you can just figure out what multiply. If this is just 1x squared, we just say what multiplies to be that and adds to be that, and then we would be done. We have it factored out. Because there's a 21 there, we don't get to do that, and we can't factor it out. There isn't a way to factor out 21. This is 3 and 7, that's 2 and 5, right? 41's prime, so you can't factor it. So what we're gonna do is the AC method, it's called. The AC method, ax squared plus bx plus c is standard form. So that's a, b, and c, the numbers in front. AC means you take this number, the number in front of the x squared, 21, times the last number, the number with no variable on it, 10. And so that's positive 210. And now we're looking, it multiplies to be positive 210, but adds up to be negative 41. So we're going to look at everything that we can think of that multiplies to be 210. And so negative 1 and negative 210. Well, let's see, does that work? No, that adds up to 211, and we need it to add up to 41. So that didn't work. Negative 2, negative 105. Nope, still too high. Negative, let's see, what's in there? 21. So 21, oh, 10 and 21, of course. Negative 10, negative 21. Nope, that's negative 31. Oh, so close. We need it to be negative 41, though. And so now you keep guessing and checking the numbers. It's sort of guess and check, but not really. That's a different technique entirely, where you're trying to break it apart into its factors. This is the AC method. So we're trying to figure out what multiplies to be this, but adds up to be that. So if you're running thin on suspects, you're like, oh, I don't know what other suspects I can think of here. I think I got them all. Look at other numbers that you already threw up there. Like, for example, there's a 7 times 3 in 21, right? So that means for sure 3 goes into it, and you can use your calculator then, do 3 into there, and 210 divided by 3 is negative 70. And that didn't work, but then what else? Well, 7, right? 3 times 7 is there, and I don't have 7 yet. So negative 7, and that would be negative 30. So that didn't work. So then look at other things that you've got, like this. We've got 10. Well, 2 times 5 is 10, right? Well, we did 2 already, but we didn't do 5. So let's try 5. 5, if you click that into your calculator, 210 divided by 5 is negative 42. So that is negative 47. Oh, and this is negative 37. So all of these are so close. What haven't we done yet? Let's look at the 30. Let's bust out suspects out of the 30. 5 and 6. Well, we did 5 already. Ooh, you know what we didn't do? 6. So let's try that. Negative 6 into 210. So 210 divided by negative 6 is negative 35. And finally, we got it. That was the one that did it. So I wanted to demonstrate a difficult AC method. I don't think most of you looked at that and said, oh, 210, that's clearly 6 times 35, and just looked like right there. So sometimes you got to work for it on the AC method like this. And that's the way to do it. If it's not jumping out at you, something that works right away, then look at other ones that you've already done and look at the pieces of those factors. 2 and 5, 7 and 3, 10 and 7, 6 and 5. 15 would have worked also. We didn't have 15 in there, but that's definitely a factor because 32 times 15. But we found the one that works. So now we bust this into negative 6x minus 35x. That's what 41, if I combine that, I get negative 41. Don't combine it. We busted it apart for a reason. So we subbed in where the negative 41 was into those numbers. And now you'll be able to do factor by grouping. Remember how we do factor by grouping. We look at the first two. So out of those two, I can factor out the greatest common factor is a 3x. So I put the 3x down, I do an empty set of parentheses, divide by 3x, divide by 3x. We get 7x minus 2. For the second one, that's a little tougher. I'm going to have to factor out a negative 5 because I want the 7 to be positive and the number to be negative, and they've got negative and positive, so it's negative 5. And then negative divided by negative is positive 7x. Positive divided by negative is negative 2. Now we get 7x minus 2, 7x minus 2. And we factored that out, so that's the greatest common factor. We write it down. We do an empty set of parentheses. And now how do I figure out what goes into those parentheses? Whatever you wrote down, you divide it out of each term. So just like how I put the little 3x there and a little 3x there, I'm going to put a 7x minus 2 here and a 7x minus 2 there. Those cancel, I get 3x. Those cancel, I get minus 5. And there it is, factored form. Not easy, not easy, okay? Nobody said these were easy. These are some of the most difficult factoring problems that you're going to be doing in intermediate algebra, all right? So number 8, 3x squared minus 7x plus 6. So again, I have a 3 out front and I can't get rid of it. Again, if this weren't there, I would just factor it and I would be done as soon as I found the combination that multiplied to be positive 6 and added to be negative 7. All right? But because there's a 3 there, that is not an option. So I'm going to do the AC method. 3 times 6 is 18. And now I'm going to look at every possible version of multiplies to be 18 but adds up to be a negative. So it's got to be negative, negative. Negative 1, negative 18. Negative 2, negative 9, negative 3, negative 6. Now, you have to play the cards you were dealt. Don't try to change the game here. We've got a negative times a negative is a positive. I've had students, many students say, oh, wait. It's negative 2 and negative 9, but if I just make that a positive 2, then positive 2 and negative 9 is negative 7. And I'll just use those. You can't do that. It's got to multiply to be a positive number and add up to be a negative number, and that adds up to negative 19, that adds up to negative 11, and that adds up to negative 9. None of them add up to be negative 7, so that is a prime. It cannot be factored. Now, since this is the second prime we've talked about, I'd like to tell you that when it's prime, that doesn't mean it's not solvable. We can solve it. There is a way to solve it. I'm going to show you how to do those in chapter 7 and 8 and 9 and 10, how to solve things that can't be factored. So don't confuse that just because it's not factorable. Prime means it's not factorable. It is solvable. We can solve any second degree equation. We can find 2 solutions for any second degree equation. That's what the fundamental theorem says. All right, so let's do some more problems. Here in 6.2. So we're still in 6.2. We're doing number 9. Factor 6x squared y squared minus 2xy squared minus 60y squared. So we can factor 2y squared out of everything, but it's still a hard problem. So we can factor 2y squared out of everything. Pull it 2y squared out of there, 2y squared out of there, 2y squared out of there. And it doesn't alleviate our problems all the way because it's still going to have a leading coefficient, right? So now look, when I cancel the y squares and then 2 goes into 6 3 times, I got 3x squared. So there's still a number there. So I'm still going to have to do the AC method, okay? The y squareds go, the 2's go, so that's minus 1x, or just minus x if you'd like. and then the y squareds go, and that's 30. So now, forget about this. I mean, it'll still be in our answer, but just block that out of your vision here. 3x squared minus 1x minus 30. I cannot factor out the 3 because that's 1. So I have to do AC method. So 3 times negative 30 is negative 90. So multiplies to be a negative. It adds up to be a negative. So we're going to go negative 1 and 90, negative 90 and 1, negative 2 and 45, negative 45 and 2, negative 9 and 10, negative 10 and 9, negative 3 and 30, negative 30 and 3. So that's everything that multiplies to be negative 90, I think. And now let's, oh no, I'm missing a 15. But I think I've got the answer in here, right? Multiplies to be negative 90, but adds up to be negative 1. That's right here. Negative 10 and positive 9. So we're going to sneak that in here. We're going to go negative 10x plus 9x. And we're going to leave that minus 30, and we're going to leave that 3x squared, and the 2y squared is still up front. So now we've got 1, 2, 3, 4 terms. We're going to factor by grouping, factor out the GCF there. So that's going to be just x and 3x minus 10. And factor out the GCF there. That's going to be 3. So 3x minus 10. And now we can factor out a 3x minus 10. You don't need this extra set of parentheses. I'm dropping that. So I'm factoring that out. And then if I whatever I write down front, I got to now populate my empty set of parentheses. X plus 3. I think we did that one already on the other page. But doesn't hurt to see it twice. Okay? So there we are with that. Let's do number 1 on the next one, factoring by grouping. Well, that's basically what we've been doing, is the AC method and factoring by grouping. So let's keep up with that. So 8x squared minus 14x plus 5. We cannot factor the 8 out to make this an easier factoring problem. And nothing else will actually come out of it. So we're going to do the AC method. That is 8 times 5, which is 40. And now we build our list of suspects off of positive 40. It's got to add up to negative 14. So negative 1, negative 40. Nope. Negative 2, negative 20. Nope. Negative 4, negative 10. Yep. I'm still going to do negative 5 and negative 8. We didn't really have to do that. That's negative 13. That's negative 14. That's negative 22. That's negative 41. So this is the one we want. It adds up to be that. Multiplies to be that. So we're going to sub that in. Doesn't really matter which one you put first, which one you put second. It will work either way. You will get the same answer regardless of which one you put first and which one you put second. All right. So now we bust out our sweet factor by grouping skills. What can I factor out of just the first two, GCF? That would be, greatest common factor would be 4x. So I write that down. I divide that by 4x. I divide that by 4x. And I end up with 2x minus 1. This one is a little tricky. I have to factor out a negative 5. The opposite of the greatest common factor. Why the opposite? Because I need it to be positive 2x minus 1. And I got the negative on the x and a positive on the number, so I gotta switch that around. So 2x. Negative divided by negative is a positive. Positive divided by negative is a negative. And now we got that 2x minus 1 and 2x minus 1. And we're going to factor that out as the greatest common factor. And then whatever you write down as the GCF, just like I did there, just like I did there, I write it underneath each term. That cancels, I get 4x. That cancels, I get minus 5. Now, I've had students ask, well, when I show my work, do I have to show this because I know it's always just the binomial is always just whatever the coefficients are. So can't I just write 4x minus 5 times 2x minus 1? You totally can. That's fine. I'm showing all of my work to explain the process so you see the process over and over again. But if you want to shortcut that a little bit because you know it always turns out to be that way, we're good. You can do it that way. All right. Let's look at number 2 on that one. We got 6x squared minus 2x minus 20. So we can factor out a 2 out of everything, but that doesn't alleviate all of our problems. It makes it a little bit of an easier of a factoring problem. So we got 3x squared minus 1x minus 10, but I'm still going to have to do the AC method. So negative 30 multiplies to be negative 30. And again, maybe you don't have to write a big list of suspects like I'm always writing out. You might look at that and just go, I knew that was 5 and 6. Do I have to do all this? The answer is no. Don't do extra work for my benefit. If you're good at factoring and you can see that this is negative 6 and positive 5, do it. You know, don't write all of this other stuff down if you know which suspect it is. Or if you want to write it down, maybe lead with the one that you really think is the one that works. And then sometimes seeing it written down helps. Okay, so that is negative 6x plus 5x. And I'm going to leave the minus 10 right there, and the 3x squared right there, and the 2 right there. And so now, what can I factor out of the first 2? Well, that would be 3x. And so then I have x minus 2. What can I factor out of the second 2? That would just be a 5. And we get x minus 2 again. And now what can I factor out of this term that I can factor out of this term? That would be the x minus 2, the binomial. And we're left with 3x plus 5. Okay. Lovely, lovely. Then the last one on this section is a process that we use a lot in advanced mathematics, substitution. And we've used a little substitution, right, back in chapter 3 and chapter 4 when we were solving systems of linear equations. Substitution was one of the methods we used. What we're doing now, though, is we're just kind of using substitution as a placeholder to make the problem a little more easy to look at, a little more easy on the eye. So look, 4r plus 1 squared plus 8 times 4r plus 1 plus 16. So now, if I had a lot of time, I could just write that out twice, do the distributive property, combine like terms, distribute that, combine like terms, and then add up all the like terms, and then it would be a really difficult factoring problem with a really high coefficient on the front. I don't want to do that. Look, 4r plus 1 and 4r plus 1. So what we're going to do is we're just going to pick a variable. It doesn't matter what. I'm picking w. You could say x if you want because it isn't an x in there. The only one I wouldn't pick is r. Don't pick r because that makes it too confusing. So some other variable, x, y, w, p, whatever you want, and say that's equivalent to that, the binomial. Now look at what we got. We'll take that and we'll put that in. That's w 16. And now I'm going to write it without the parentheses. And check it out. Easy peasy lemon squeezy. Now it's a factoring problem. And an unfoiled factoring problem at that. So not even a factor by grouping or anything. We just have to figure out what multiplies to be positive 16. That adds up to be 8. So we got 1 and 16. Or we got 2 and 8. Or we got 4 and 4. Well, 4 and 4 did it. So we go right to the factoring step. This isn't substituted in and factor, by grouping. It's a 1w squared. So we just get to go right to our answer, w plus 4, w plus 4. And now there is an extra stage to this problem. That is done, we have factored it. But what we basically did was we put that w as a placeholder because this was hard to look at like that. Now we have to put that back in. So where there's a w here, I'm going to write a 4r plus 1. And when there's a w there, I'm going to write 4r plus 1. And now I have to combine up the like terms. So see, there's some like terms there. So this is 4r plus 5 times quantity 4r plus 5. And now we're done. Oh, I guess if you wanted to be fancy, because it's a perfect square trinomial, you could go wham squared. You can only do that when it's the exact same binomial twice. All right? Awesome possum.